So, as you know, my name is Andrey, and I'm going to talk today about some infrastructure as code patterns. How many of you guys actually write any infrastructure as code? As developers, as sysadmins?
What is it?
Oh, you do, I know. What is it? Okay, most of you.
You copy from Stack Overflow.
Yeah, of course. Right again.
Did you ever have a feeling that sometimes all the code that you write for automating infrastructure is just ugly? Did you have that feeling? No, you write clean code right away, right? Okay, let me jump into the presentation and see what kind of patterns I have seen during my journey, during my professional experience, and see if you have the same experience. So I guess it's not that much to say about me. I'm Java and Groovy developer primarily, but last few years I've been doing a lot of DevOps activities and automation activities. And you can find me on Twitter if you want, but that's not interesting. Let's talk about what was in this talk. And mainly, this is a collection of patterns and anti-patterns that I found, that I've seen many times in different code bases for representing infrastructure as code. This presentation in general is a work in progress, so it's never done, and I'm trying to collect more patterns over time. So if you guys have something else to add, and if you think that some patterns are not good enough or not detailed enough, please give me your feedback, ask questions, and yeah, in any way. So, what is infrastructure as code? We can take this quote from the most trustful source on the internet, Wikipedia. Well, it's a type of infrastructure that operations teams can automatically manage and provision through code, rather than using manual process. I guess more or less most of you understand what it is. It's any code that allows you to manage your infrastructure, to create your servers, to deploy your applications on them, to provision them, to monitor them. All of that is infrastructure as code, especially if it's really run as code, not just stored somewhere. Nobody gets access to that. So code should be active, and code should be executable. Otherwise, it's not infrastructure as code. During my years of experience, I've found that, in general, the infrastructure as code can be divided into three main areas where you can apply different set of tools. The first one is images, so base images of your operating systems, of your Docker containers, of anything that stands up to your environment. So, and there's a set of tools that supports that. The next step is more live, because images usually are kind of more less often changed. So when you have an image of environment, you reuse it often, but you don't change it often. The next stage is declarations, where you can actually apply more often to your infrastructure, and this basically declare what kind of state you want to have in your environments. And if we talk about tooling here, then tools like Puppet, Chef, Ansible, in some way Docker as well, can live in this area. And the last one is a more ad hoc approach, when you have to do some stuff on top of your infrastructure, like orchestrate deployments, clean caches, update minor settings, something that is executed often, but something that doesn't declare the initial configuration of your application. Something that is done less often, but on a less regular basis, I would say. So three areas. And here, basically, all the scripting tools that can think of, they live in this area. So if we just depict the picture as a list, so we have image definitions, we have provisioning declarations, and we have automation scripts that all together form your infrastructure as code approach. And tooling-wise, this is more or less. Well, again, there are a lot of tools, and I'm not going to mention every possible tool, because I think every day, or at least every month, there's a new tool appearing on DevOps, in the DevOps ecosystem. So there are many tools, and for image creation, we have Packer, we have Docker, we have different clouds that provide us with APIs for creating images. For state declarations, we have Puppet, Chef, Ansible, Salt, a lot of other tools actually. And for automation blocks, we have basically SSH connectivity and shell scripts, plus any APIs that are exposed through file infrastructure, cloud APIs, plus your favorite scripting language that you can use to do that. So it could be Bash still, it could be Python, it could be Ruby, it could be Groovy, anything. So all of that combine your infrastructure as code together. So it's not only one tool, it's everything combined together. And this is a nice table that was published by a company called Xavier Labs. They also position themselves as a DevOps company. They do a lot of software automation. They created this periodic table of DevOps tools. And I think it still doesn't mention all of the tools. And you can easily find this picture because I'm not going to go inside every tool and describe what it is. Besides, I don't know all of them. But you can get the feeling that there are a lot of tools. And they basically, for different groups of tools, they use different color. And you can find the picture in the internet. No big deal there. But the main idea is that everything is code. Everything that you can apply to your infrastructure, to your deployment procedures, to support and maintenance of your production systems, everything is code. You don't need to potentially involve in a lot of manual processes and store as much as possible in form of the code inside, obviously, in the version control, because that's where the code should be. There's no other place for that. The code should be in the version control. If you store it on a shared drive, if you store it in your email, that's not code, that's something else. And of course, the only way your code is getting onto the environments, into the servers, into the containers, into whatever you use for that, is through automation. There should not be manual processes involved in general. And the same is true about applications, because I doubt that most of you deploy applications manually. That doesn't happen, at least in a majority of organizations. It's done through automatic process. The same should happen with infrastructure as code. You should not take code and execute it. You should have an automation process behind it that actually executes it for you. And this could be one click away. So it could be like your CI server having this big deploy button to deploy to production, or actually it may behave in the same way as an application does. So if there's something as code in our version control, we do a commit. Why not initiate any automation process on top of that? So if you commit some new changes to your infrastructure as code, to your new image definition, to your infrastructure definition in Powder or Chef, why not to make some process that actually takes it and puts it in infrastructure? That's how it should be, because that's how we do with code as well. Okay, let's see some patterns. That's the kind of the meat of presentation. The first one that actually I think exists for a long time, is the longest, is the pattern I know for the longest time. It's called golden image. Basically, it's an operating system image, or now we can also call it a container image or something. But usually it's referred to operating system image, which is crafted manually, and this is so hard to change that nobody is just actually daring to change that. So all your new servers are created from that golden image, and whenever you need to do a change to that image, or whenever you need to update servers that are created from the old version of the image, the process is manual, painful, and basically you end up having very unique and under-configured or over-configured environments, resulting in a lot of manual work. So golden image is something that is a bad thing. On the other side, there's another pattern called reproducible images, where you have an ability to actually create your image from scratch at any point in time. And the tools for that, usually the tool that I use for that, for example, is Packer, which allows you to create this kind of images from a normal starting point and put additional scripts on top of that. So Packer is a tool that allows us to create with a single command, we can run the process of recreating our base image and updating that with some additional stuff. We can put a baseline for our environment through recreating those images. Also, Docker has built a tool for that. Basically, Docker is the tool that can do that for us from a Docker file. Create a pre-made container image that can be reused by containers. Another pain point that I've seen a lot, and that's something that many organizations actually forget, is that, well, everything is code. I told that everything is code, but secrets, it's not code. It's something that should be stored isolated and should be not committed to version control in an unencrypted form. You have to realize that secrets is something that should be stored in separate locations. So secret isolation is a good pattern. Well, when you start designing your infrastructure as code, when you start writing code in Ansible and Shad and Puppet, or in Docker as well, you have to think about security. You have to know that some of the things like private keys and passwords, they should reside somewhere else. And of course, if the sharing, if secret isolation moving out is kind of is a code pattern, so something that you have to design into the code. On the other hand, you have also to encrypt those secrets and store them secretly either in the version control or in some sense secure vault, which allows you to not share them with everybody, but and control who has access to them. The different options to encrypt the stuff. You can of course encrypt your whole hard drive, but it's probably not the best option. You can also encrypt files directly in the version control. It's also possible. Or you can use some vault service, which allows you to store secret in some shared server location, and you can access that vault service from your infrastructure as code or from your laptops, depending on how it is set up. So one way to encrypt things is use GPG, for example. So you can actually encrypt sensitive files or sensitive configuration, private keys, with GPG and store that file in the version control. This will be safe because unless, and of course, the password that is used to encrypt that stuff, the key that is used to encrypt the sensitive file, should not be shared in version control. It's shared in a different channel, through email maybe, through I don't know, SMS if it fits into SMS. But in general, this should be done outside. Another useful thing, which I use it a lot now, and thanks to Edwards actually, he showed me that thing, and we use it also in LabCraft. This is basically a hook for Git, which allows you to automatically encrypt files upon commit, or actually upon push, I think. So basically, you say inside the Git attributes, you say which files you want to encrypt, and you define it with the filters, special filter called crypt, and then whenever you change that file, it will be encrypted and pushed in an encrypted form to a remote server. But locally, when you check out the file, or when you pull the file, it will be decrypted automatically for you. So locally, you will always have a decrypted version, but remotely, you will always have an encrypted version. That's a very good way to hide secrets and still store them in the version control, together with the other code. And talking about security, another thing that, as I already mentioned, people tend to postpone secret isolation. People tend to not encrypt secrets, and it may be okay for the first couple of weeks of the project, but later on, you must think about, at least on minimal level, about security, about the risk that you have. Especially if you're going to use the same code to deploy to development and to production, you have to think about security beforehand, because otherwise you are at risk and your team's at risk. Next pattern. Next pattern is called infrastructure component DSL, and this is something that this is something that is kind of close for me as a developer, because when I write code for my applications, I like using abstractions. I like defining things that define the domain of the application, and I like using those abstractions. And I guess most of you guys who are developers also can like doing the same, because if we don't need to create those abstractions, then reading our code would be very, very hard. And the same is true actually about infrastructure as code. And some of them actually allow you to write a simple DSL, or simply they provide a construct that allows you to create abstractions inside infrastructure as code to create more readable definitions of your infrastructure. So, for example, imagine that you have a system that has made So some base components like HTTP proxy, HTTP application, and you have a database. Okay, quite normal architecture, something that may be very specific to your organization, but again, at the same time, this is something that everybody will understand within the team, because if it's HTTP application and you know the parameters, then everybody knows what it is. They don't need to go inside the files and realize what's going on. You put the intent of your configuration on top of your code. So you basically use the clean code teachings and allow you to define the most high-level abstractions on top, and low-level details go beyond that and go in some other files and some others, some deeper structure inside the code. And the thing is that it doesn't matter what you use. It doesn't matter if you use Bash, if you use Perl, if you use Python. You still, as a developer, as a writer of the scripts, you can still write readable DSLs just with functions, just with basic abstractions that the programming languages give you. And also the tools like Puppet and Chef and Ansible, they also give you these abstractions right away. They give you the facility structure, group different definitions into one higher level abstractions, which you can use to describe the system better. Okay. By the way, how many of you guys use tools like Puppet, Chef, Ansible, Salt, Docker? Anything else? Okay. So one problem that I've seen with tools like Puppet and Chef, that people tend to use this tool as a fancy file copying utility instead of reusing all the possibilities that the tool gives. They just take all the configuration files and they copy them over using Puppet or Chef syntax, which actually doesn't make a lot of sense because you don't produce any value. You can actually write the same script with Bash with much fewer lines instead of converting that stuff into very large Puppet manifest, for example. So imagine that you have Nginx. Who knows Nginx? Okay, great. Well, it's an HTTP server for those who don't know. And let's say you have these files which configure Nginx. And then you have a Puppet manifest or a Chef cookbook or Ansible playbook, which basically copies all those files. What information does it give to the reader of this code? Well, nothing. It just tells you that it configures Nginx in some way that nobody knows how. But and the thing is that this usually hides your intent. This hides your actual configuration from anyone who will read that code later on after you. So in case of Nginx, what you actually want is actually to configure, let's say, an upstream endpoint, the server you want to connect to. You want to configure a virtual host with the host name. That's the intent of your configuration. You're not copying files. You're actually configuring some components of your system, which is much more important information to the reader of your code rather than it's just much more important information in my opinion, because it provides the intent of your configuration and it reads much better. And in that regard, also speaking about fancy file copying pattern, we can also apply for that using incremental configuration. So instead of copying everything, all possible default state of the package that we want to configure, or the application we want to configure, we actually can just change the values that we want and to inject the configuration that we want. For example, some of the tools, some of the packages support a mechanism called conf-d, where you can inject additional configuration blocks into a default configuration. So you don't need to update all the files. You can just inject what you need. And having this incremental configuration approach, you can also combine different applications running on the same machine, on the same container, without any problems. Because if you copy everything, then you lose the ability of combining configuration, because every script, every Puppet manifest, every Chef cookbook thinks that it's the only one on this machine to manage this particular package. And at that point, you lose the capability of running several configurations, let's say the same Nginx. on different applications. You actually, because you have to redefine that state once again. Yeah, simple examples of incremental configuration. You know, instead of configuring full SSH access, instead of replacing full SSH configuration, you can actually just do a pinpointing of specific things, like configuring on this library access, or doing some minor configuration of Linux. And well, there are many examples. You don't need to reconfigure the whole component unless you really need it. And usually the default state is more or less known, unless of course you deploy your application to random servers and random operating systems. Then it's a problem. But if you know your infrastructure, if you know your base image, then having this incremental configuration approach is quite beneficial, because you express your intent much better, and the configuration is much more reusable. And just speaking about tools in here, which you can apply using this incremental configuration approach, you can use just plain old regular expressions to do file line replacements, for example. In Puppet, you have file line module resource type and OGS resource type, which are quite advanced. Especially OGS is quite advanced. You can do very fancy stuff. In Ansible, it's line file and replace. You can use that. In Chef, because it's just plain Ruby, you can use any Ruby facilities that are provided there. And jumping from incremental configuration, we can go also to configuration composition, because this is what gives us an ability to compose configuration. So if we have several different components lying on the same system, on the same server, then we can combine those blocks and do injections to plugin support and stuff like that. And this only is possible with abstraction of the component. Again, just some examples from Puppet is concat module, from Ansible is assemble module, from Chef is called special constructor partials. You can use those to actually concat several things into one thing. And you can inject configuration blocks in later configuration dependencies if you want. Another thing that is becoming popular, or I think it's already quite popular in DevOps communities and in DevOps, in organizations that practice DevOps, is instead of configuring your stuff and putting all possible options into the provisioning code, you actually let the applications, the system, to discover those components automatically from discovery services. This makes the provisioning scripts much simpler, because you have to take care of less things to configure, and some of those configuration options becomes more dynamic. And there are several solutions for that. And again, this is not the only ones. So there are tooling for configuration exposing configuration through auto discovery services, and also you can use those to get specific options, to get specific IDs or DNS names or IP addresses and stuff like that. Something that cannot be injected, or something that is so dynamic that you have to jump on a different level. Another thing that could be important to minimize your infrastructure as code in general, or actually to isolate some of the steps, how your code, your application, or your whole architectural component set is getting onto the system. You can actually use additional packaging layer, and instead of writing some Puppet scripts or Chef scripts to describe how your job application, how your Ruby application should be deployed and configured, you can package it as an RPM. You can package it as a dev package, and build in some of the useful defaults, some sensible defaults into that package. And instead of writing additional provisioning code around deploying your application, you just use the package and deploy that. And of course, tools like Puppet and Ansible, they support abstractions like package from the ground up, and they know about it, and it's quite easy to write that code, like one-liner basically. So if you have that ability to package the code, don't do that, because it will minimize the infrastructure as code for deploying the application. Because you express some of the things earlier in the process, and you release that part as part of it. The same actually goes for Docker images. It's one of the packaging formats actually that is now being used and developed, and you can benefit from that. So, and you can start as early as packaging your application with Jam or Jar, or just a zip file, like troubleshoot to some artifact repository, or you can go further for operating system packages, or even having an image or a container image to do the same packaging stuff. It may save you some time during the deployment process. Antivirus, data as code, something that I've actually seen a lot some years ago. Well, the thing is that data is more, it has a different cycle and it's more dynamic. But sometimes people use provisioning tools to actually put configuration that looks like configuration but actually is data. So for example, one of the most popular examples that I've seen is that people use provisioning tools to define organization users, team users. So instead of using something like LDAP, they use Puppet manifests or Ansible playbooks to define the whole list of the users that they have, all the groups of the users that they have. And obviously, if you have 10 users or 5 users, that's fine, that works fine, that's not a problem. But when you have 100, 500, that doesn't work, because that means that at that point you have to use LDAP, and it should be HR's problem, not a system administration problem, to actually add users into the system. You should delegate the capabilities there. So as soon as you see that your provisioning infrastructure code is growing in the wrong direction, you have to stop it and to delegate the work to someone else. So you can also use configuration data source for configuring some of the stuff, combining configuration data with the templates, with the Ansible scripts and Puppet manifests, and then you can start as simple as with data file stored somewhere, and it could be a database, it could be a service API. So if the data starts to be quite big, then putting it into manifests is a bad thing. But you can extract it and make it as a data source. So LDAP is a data source, and then any other database is just a data source which you can inject during provisioning phase into your infrastructure as code. Also, that's also quite common, not only with infrastructure as code, it's also quite common with any code, unfortunately. People tend to ignore styling guidelines, especially with the tools and with the languages that they don't know, although it's something that they learned like yesterday. But the thing is that Puppet has styling guidelines, Ansible has styling guidelines, Sharp has styling guidelines, and they have good examples on GitHub, on the internet, so some on the internet, which show you how to write good and bad, how to write good code, how to write readable code, and how to adhere with the standards that are put by the organizations behind those tools. And unfortunately, there is a lot of examples that are quite bad. But if you're jumping into the direction of automation and you're using a new tool, try to find those guidelines. Try to find how other people, how like recognized experts in the area you write the code, and try to follow them. Don't try to follow bad examples, because it's already enough with bad examples in the map. Another antipattern that's also pretty common, that's not treating infrastructure as code. Basically, if it's code, it's must be version control. If you don't put your scripts in version control, that's bad. Code reviews also help. I mean, it's code again. You have to review the code. It doesn't mean that it has to be periodic, but at least in the beginning, you have to consult with experts and try to make the code look as good as possible. Also, in fact, for some of the tools, some of the tools like Puppet and Ansible and Sharp, there are static code analysis tools that you can apply to at least get an understanding of some styling guidelines that you violate when you write the code. Also, you can actually test the code, especially given the virtualization that we have at the moment, all the virtualization options that we have in Amazon, in Azure, in Google Cloud, or also locally, you can pretty much visualize a lot of stuff. You can do integration testing of the provisioning code that you write. It's not a big deal. I mean, it's not that hard actually. It maybe takes a bit of time compared to unit testing, of course. But if you want to create the code that provisions your infrastructure and that leaps from dev to create to prod, and that it works there, then some sort of integration testing is definitely needed. Another one that, oops. Basically, it's a situation when developers think that they may be, well, since it's code, code is developer thing. They tend to write everything themselves, and it may end up in a situation when things do not work well. So somebody forgot to back up things. Somebody forgot to hide the secrets. Somebody forgot to configure the Linux system to best performance. Somebody forgot to configure SAND to have enough space. So if developers tend to think that we have enough experience, we have the API, we just use it, it may end up in a better way. So we have to leverage experience from operations teams and let them also contribute to the code. And one of the problems that come with here is if development realized quite late that they didn't think about many operations problems, then we can have this situation. So there's development happening, then we have some QA phase where at some point QA says, okay, it's okay, we have found all the bugs we can't find anymore, and then you get this package and you throw it to production, and suddenly it breaks, and you have the number of issues growing rapidly because you haven't thought about monitoring, about backing up, about performance, about all of those stuff that are important for operations while supporting the application, and late alignment with operations may be a problem. And speaking about application support in production, it's also quite important that your application is monitorable, because this is the only way to understand what is going on and what are the KPIs, what are the main metrics that show that your system is alive and then working and bringing money. And I have often seen that sometimes, all these metrics around your system that are configured manually with some monitoring tool. SysOps guys go either into the monitoring tool and configure that manually. And the thing is that sometimes, well, actually quite often, application architecture changes. You add new components, you add new database schemas, you add new endpoints, and you have to inform your operations about those changes because they have to monitor those new endpoints, new things in the system. And if they don't have an ability to know that, it may come as a surprise. And I've seen a lot of times when this comes as a surprise. You deploy a new application, and and the operations team doesn't know if it works or not because they only can monitor like CPU and disk space, but they don't know the main application metrics that are important for application to be alive and probably bring money. And metrics as code could be one of the solutions to solve that, because when you develop an application, you can actually also develop the monitorability of that application together with the application code. So whenever you add a new component, you can change the metrics that are exposed by application. And expose it as code, and also design dashboards and stuff like that together with your application. So this also will solve some late alignment issues because people in ops team will have the dashboard, they will understand what this application is capable of. Yes. And there are some tools, well, I've seen some Java developer, there are some tools in Java space that allows you to expose some of the metrics and create some of the dashboards, like drop visit metrics, historics, stage monitor. Okay, actually I'm running out of time.
How much slide do we have?
Many.
100?
Well, give me 5 more minutes, I'll finish it. So another pattern is control panels code. I guess most of you guys have CI server, continuous integration server in your organization that is doing mostly dev-related stuff, but also it is possible to use obviously the same tool to do deployments, to dev, create, production, or wherever you want. So, and also what I often see is that CI server, like TeamCD, Jenkins, is basically a manually crafted beast. So nobody cares about what is the configuration, how it is stored. And when you create a new job or a new plan inside your CI server, it's usually copied from the other one. And basically, to change that stuff, you have to jump around your UI and configure that. But the thing is that most of those tools, like Jenkins, TeamCD, and others, they do support extraction of the configuration, storing it inside version control, for example. In case of Jenkins, I can recommend like Jenkins API. Jenkins has an API, obviously, and also has a job DSL, which you can use to define the jobs that you want. That makes your Jenkins reconfigurable and reproducible. And also there's a great plugin that leverages the job DSL. Also, if you use, for example, Rundeck, it's another CI tool. There's also like an API tool that you can use to leverage to deploy the configuration of the CI server, of your control panel, which allows you to control your deployments and builds. You can get the configuration stored in version control. Another anti-pattern. Unfortunately, there are a lot of modules available for Ansible, Chef, and Puppet, but not all of them are of good quality, unfortunately. And I think one of the reasons that there's a lot of bad code there, is that people do not share back the changes. So what usually happens with infrastructure as code, when you see a good module, some module that seems useful but that doesn't really fill your use case, you take it in and you basically modify it for yourself. You never share it back. And I think that's a problem with all the Ansible modules, all the Puppet modules that are out there, because some of them they're really basic and they never grow up with something better. And that's because people don't share back. So I think it's important to share back your infrastructure as code, because this will benefit the community. Because you're benefiting from the community by taking the model in, but you're not fitting back. And as one of the things that, if some of the modules maybe not designed very well, but still quite useful, and one of the ways you can handle it within infrastructure as code is create a community module wrapper. Basically, instead of making a copy of the module inside your code, you can actually make a wrapper inside that code, and inside the code, and still have dependency on that module. Well, that's my favorite antipattern. I have to sell it. So, and then actually, it's not really related to code that much, but it's more related to how team members are thinking about the code. So imagine you have this kind of structure in your DevOps automation Git project, and I guess you can see that the naming conventions are maybe okay, but at least they all are lowercase, and you can understand that it's maybe more or less what each one of them does. Then at some point, another guy comes in and he wants to help, but he just doesn't know how, and still he produces some scripts that he doesn't know how to execute. He executed them once, but he doesn't know how to put them into the main flow. So what he does, he creates a directory called other stuff, which first of all violates the naming conventions, obviously. Maybe this guy comes from Windows background, because in Windows they use camel casing, and obviously this contradicts all the rest, which more seems like the Linux background guys. So usually what this tells about is that the team members are either not talking to each other, or they do not have the shared goal or shared understanding of what they are creating. And this is definitely an indication of the problem. Okay, maybe I should finish on that, because it's or should I continue? Okay, let me quickly jump over the others. Another one is automation over documentation. So I know some ops teams prefer to create lengthy documents describing all the procedures with all the manual steps that need to be taken in order to create an environment. That's bullshit, because code doesn't better. If you express it with code, if you put it in the version control, you first of all have the version, you have the history, You have the who did that and the why did that. Why he did that in form of command. And this works much better because if your automation is really automation, if it's really alive, if the code is executed all the time, it reflects the reality much better than the outdated documentation that somebody created 10 years ago. Another one, environment template. Basically, if you have a set of servers that you have to configure, a set of containers that you have to configure for your environment, you have to, you can express it as a template. So for some tooling that exists there, like in background, you can start multiple machines with the same background file. You can use AWS CloudFormation in AWS. You can use Docker Compose. You can use Kubernetes API to start containers if you want. And of course, you can create mass out of anything. So big ball of mud is applicable to any code. And yeah, sometimes I see this stuff in infrastructure code as well. There's no escape. So summary of patterns. This is a lot of philosophy slides. So the good patterns, reproducible images, secret isolating, encrypted secrets, infrastructure component DSL, incremental configuration, configuration composition, configuration discovery, extra package code, integration data source, metacast code, component bundles code, community module wrapper, infrastructure query language, automation of recommendation, and environment template. And anti-patterns, golden image, postponing secret isolation, fancy file copying, data as code, ignoring some guidelines, nurturing EVS code, DevOps, private core, community module, other stuff, big more fun. That's it, guys. Thank you.
How much time does it take to learn Puppet from scratch to be able to write parameterized modules?
Well, it depends who teach you. I think if you have a goal of learning how to write Puppet modules, parameterized Puppet modules, then you can do it within a couple of weeks. If you don't have that goal, if you just have a goal to just use Puppet for something, then it will take some time.
Right.
Yeah, because I think at the moment Puppet documentation is getting better, and also they have good tutorials on some of the things, including this one. And plus, they improving the Puppet itself with additional structures that help you out to create parameterized modules better, especially with higher support and this kind of stuff. It definitely was much harder like 5 years ago.
I had experience about 2 years ago. Actually, it took me a few months to write testable parameterized. But it's my speed. Just curious.
Well, speaking about the different tools, I think Ansible has the shortest learning curve. Puppet, because of its long history, actually has some quirks that you have to know about and have to especially the dependency management between resources. That's the worst thing in Puppet, unfortunately. But it's still quite a good tool in my opinion. But yeah, it takes some effort. So if you want to start with something, then just start with Ansible. Then look at other tools. And I hope something else will appear because I hate all of them. More questions?